Hello everyone, welcome to this new playlist Digital VLSI Design. In this playlist we are going to cover all interview and online test related questions. Here is few things that I have mentioned regarding this playlist. Okay, let's take our overview. We are going to cover in this playlist from very basic logic level design to advanced design. Each lecture you will see we will focus on important interview questions that asked by the companies. We will solve problems step by step to understand the core concepts. Definitely, we will discuss some few common mistakes that we are did in the interviews and online test. Since I am a working professional in VLSI industry, so I will try to connect these concepts with real VLSI industry designs. Okay, let's start with fundamentals questions that ask why the companies in interview as well as in the online test. Okay, let's move towards the question. So the first basic question is what are the logic gates in digital VLSI design? So the logic gates are basic building blocks of any digital circuit that can take one or more binary number as an input and produce a binary output based on the logical operation. So the first basic thing that we need to keep in our mind about the logic gate is these are the basic building blocks of any digital circuit that can take one or more binary number as an input. The number should be binary only. It can be a 0 or 1, and based on the logical operation, they produce the output. The logical operation can be a logical addition, it can be a logical multiplication, it can be a inversion. Based on the logical operation, these logic gate categorized under three category. First one is basic logic gates, basic logic gates. Second is universal logic gate, universal logic gates. And third one is arithmetic logic gate, arithmetic logic gates. So now we will see one by one under which category which logic gates lie. So first we will look in the basic logic gate. So under basic logic gate, first gates that come and logical gate. Second is or logical gate, and third one is not logical gate. Now we will see under second category which gates lie. So under universal logic gates, first gate is NAND logic gate and second is NOR logic gate. So under universal logic gates, only two logical gates lie. And now we will look in the last category, that is arithmetic logic gate. Under this category also two logic gates lie. First is or XOR logic gate and second one is XNOR logic gate. Okay, so under these three category we have total seven number of logic gates. From this question we have understood what logic gates are in the VLSI design. Okay, let's move towards the second question. The question is explain the functionality of basic logic gate in digital VLSI. So we will see the each logic gate functionality in this question. Let's start. As we know, there are total seven number of logic gates. Let's start with first AND logic gate. So the functional definition of AND logic gate is when all input will be 1, then only the output of AND gate will be 1. So from here we can say if the output of an AND logic gate is 1, then all input must be 1. So that is the definition of AND logic gate. Now let's see the symbolic representation of a AND gate. In general, basic logic gate has two input and one single output. So according to that, we will draw basic symbol of AND logic gate. It has two input. We are calling one input as A and second input as B, and the output single output is as Y. So the Boolean algebraic equation will be Y is equal to A into V. Let's draw the truth table of AND gate. Before that, we will understood what is the truth table. So truth table is nothing but it is a table that lists all the possible combination of inputs and their corresponding output. So we will see in the truth table how we are writing all the possible number of inputs and their corresponding based on the functionality. So first we will calculate what is the total number of possible inputs. So if there is two input binary inputs, so how many possible number of input? 4. How we are calculating? Based on this equation where n is the total number of binary inputs. So how many inputs we are having here? 2. 2 to power 2, that comes 4. Based on this Boolean algebraic equation, there are 4 possible combination of inputs. Now we will draw the truth table of this AND gate and observe the output behavior. So first we will write the input as we are having two binary inputs A and V. Now we will write first the possible number of value of these two input. First the A and V both can be 0. Second will be A can be 0 and V can be 1. And third is A can be 1, V can be 0. And last one is both can 1 1. Now we will see the input value in truth table and write the corresponding output. For that, first we identify where all the input are set to logic 1. So if we will observe one by one input pair values. So in first case both are 0, in second case 1 0 and 1 1, and third similar as second, and the fourth input pair has both input logic 1. So for this we can clearly write the output as a logic 1. For the rest of the case the output should be 0 only. From here we can write one more definition about the AND gate functionality. If any one input of a AND logic gate is 0, then the output will be always 0 regardless the other inputs. That we can see in the truth table clearly. Okay, now hope so this AND gate functionality and the behavior is clear. Now we will see some basic interview questions. So here are four questions that I have mentioned. One by one we will see the output behavior of this AND gate based on the functionality. Let's start with first question. So here are two inputs in which one input is set to 0 and second is A. So we will see 0, and we know if any input of AND gate is 0, then the output is 0 irrespective of the other input. So here we will see simply 0 in one input, then we will forget about the second input. Simply we will write out the output as 0. Now we will move towards the next question. Now there are also two inputs. One input is set to logic 1 and second input is A. Now if you will observe the truth table, here when one input is set to logic 1, then the output is directly as same as input 2. So from the truth table we can say if one input is set to the logic 1, then output will be the second input. So simply we can write according to the truth table here also, because one leg is tied to 1 set to the logic 1. So the second input will be the output of this question. So what is the second input here? A. Okay, now these are two more questions that you need to solve and comment me the answer in the video comment section. Let's move towards the next logical gate, that is OR gate. Okay, first we will discuss the functional behavior of OR logic gate. So the output of OR logic gate will be 1 when at least one input of OR logic gate will be 1. So from here we can clearly see one thing about the OR gate. Whenever at least one input of OR gate will be 1, then automatically the output of OR gate will be 1. Okay, we will observe the output behavior of OR logic gate in truth table as well as. So now let's draw the symbolic representation of OR gate. Here again I am taking two input OR logical gate for the symbolic representation. So the symbolic representation of OR gate looks like this. This will be the output Y, and the first input I am taking as A, second input I am taking as V. Then the output expression and the logical Boolean algebraic equation will be A plus B. Okay. Now let's draw the truth table for more clarity. As we know, we have two inputs. So how many possible number of input will be? 4. We have calculated in OR gate. So what will be that? 0, 0, 0, 1, 1, 0, and 1, 1. Now we will see the input value in truth table and write the corresponding output based on the OR gate functionality. So according to the OR gate functionality, if any input of OR gate will be 1, then the automatically output will be 1. So we will first observe the input values. First see the first pair of inputs. Here A is 0, V is 0. So here we are not able to see any input as 1. So simply we can write this 0. Let's see the second pair. Here A is set to the 0 and V is set to the logic 1. So here we can see one thing. At least one input is set to the logic 1. So for this case, the output of our logic gate will be 1. Now we will observe the third input pair. Here A is set to the 1 and B is set to the logic 0. So here also we can say at least one input set to the logic 1. So for this case also output will be logic 1. Now we will see the last pair. In this pair both value is having logic 1. So for this also the output will be logic 1. We will observe the truth table, then we can able to see for the first case only the output of OR gate is 0. For the rest all case the output of OR gate is 1. So from here we can conclude one more definition of OR gate. The OR gate output is 0 when only the all input of OR gate are 0. So you can see in truth table, if both input are 0, 0, then only the output of OR gate is 0. And for the rest of the case, the output is OR gate is 1. So now we will see some basic questions of OR gates. Okay, let's move towards the first question in which we need to write the output value for this logic gate. It is having two input. One input is logic 1 and second input is A. So we know whenever our gate is having at least one input as logic 1, then we can simply write the output for that logic gate is 1. Now let's move towards the second question in which again we need to write the output expression or output value for this OR logic gate. It is having A input and logic 0 input. Now if we will observe the truth table, then you can clearly see whenever a logic gate is having logic 0 input, then the output is directly as same as the second input. Like you can see the value of A here and the value of V here in truth table. So when the value of V is 0 and 0, then what are the outputs? 0 and 1. So what is the 0 and 1? We can see in A input value. A input value is similar to the output value. So from this we can conclude one thing. Whenever the OR gate having two input and one input is tied to 0, then the second input treated like a output of that OR gate. So the what will be the output for this OR gate will be A. Now we will see these two questions. Okay, these question I'm giving as a homework for you guys. Just need to you need to comment the output of these two OR gates in the comment section. Now let's move towards the next basic logic gate, that is NOT. NOT gate is a very basic and fundamental block of VLSI design. Okay, let's observe its output behavior. So the output of NOT gate is complement or inverse of its input. So we can say the output of NOT logic gate is nothing but it is the complement or inverse of its input. Okay, let's draw the symbolic representation of NOT gate. NOT gate is having only single input, single output. So this is the input for the NOT gate and this is the symbolic representation and this is the output. So and as I am taking the input as A, so the output will be Y is equal to inverse or the complement of input, its input. So the what will be the complement of A bar. Okay, let's draw the truth table. As we know, it is having only one input. So how many possible number of inputs will be present in truth table? 2, 0 and 1. And let's write the respect output value. If input is 0, then we know the output will be the complement. So what will be the complement of 0? 1. And if input is 1, then what will be the complement of 1? 0. So 0 will be the output. Okay, so till here we have covered these three basic logic gates: AND gate, OR gate, NOT gate. Now we will cover the remaining four logic gates in upcoming video. Let's see few questions related to these logic gates. Here I have mentioned each and every question input value, and you need to calculate the output expression and the output value and comment the output in video comment section. Okay, so I hope this knowledge is helpful for you. If you have any doubt related to this topic, just comment me in video comment section. I will definitely clear your doubt in upcoming videos. Stay connected for the upcoming video. Thank you everyone for watching this video till end.